So I'm Barry Stahl. I'm a solutions architect and developer at US Airways. And my group, I'm primarily responsible for crew operations there. So my primary customers are the people whose job it is to make sure that the crews are in the right places at the right times to fly your airplanes. So the next time you take a delay because there's no crew there to fly it, I guess you've already got my contact information. My group primarily does integrated systems work. So we do a lot of pulling data in from like various crew systems, along with flight operation systems, gate systems, et cetera. Bring all that data together into our SOA, and then serve out that data either through events, through services, or occasionally we write applications on top of that data ourselves. US Airways is very good to me. They allow me to fly around the country and give talks like this, so I really appreciate that from them. And that's what I spend my days doing. By night, I am focused on Arizona GiveCamp, and in fact, GiveCamp in general. I'm on the National Board of Directors for GiveCamp. Now, GiveCamp, for those who are not familiar with it, is a weekend event where software developers come together with a bunch of charities, and in the course of a weekend, build from nothing to whatever it is that charity needs, and by the end of the weekend, turn over that code to the charity in a way that hopefully they can support it themselves. We do a lot of great work for a lot of great charities, and generally they're local charities. So if you're interested, there is one being developed, I understand, in this area, although I have no idea who you would contact about that.
You got a website?
Yes, you can keep an eye on givecamp.org. And it is the coolest thing you'll ever do with code, just so you know. So I like to start this talk off by going through a lot of background information. Why do tests? Why do test first, etc. But I think most of that information is better served. We're better off just by spending more time in the code, I think. And hopefully you won't object to that too much by spending more time in Visual Studio than me blabbing at you. But there is some information that you probably might want to have access to. So I did take it and put it up on my blog, which is Cognitive Inheritance. And it morphed into, it was a blog post at one time, but it morphed into an FAQ. And that's always available on the top navigation under the unit testing and TDD FAQ on cognitive inheritance. The other things you'll find there are the code samples from this talk, including the completed version of the application we're going to build today. So this is what we're going to build today. The goal here today is to kind of walk through a unit testing session, a TDD session in an Agile environment. And there's really no better way to learn how to do test-driven development than actually pair up with someone who knows it and start doing it. Now, I'm not a huge fan of pair programming. I don't have the patience or attention span for it. But in this case, I think you and I, we're going to pair up and we're going to write some code here. And I like that because I get to drive. So then you won't be getting any turn today. Sorry. So let's build an application here, and we're going to build a fairly simple app today. My group at US Airways makes a lot of use of message queues. And message queues are valuable. They're good for a lot of different reasons. There are a number of reasons why we use it, but one of the primary reasons is that it gives you a touch point into the application, a way of looking at the app and seeing what's going on inside. So we can look at a message queue and tell maybe if it's not getting any messages moving through it, that maybe the source to that queue might be having a problem. And likewise, if it's filling up, the draining app might have a problem. So it gives us some visibility into the process. But every queue is different, and every process is different, and sometimes these processes are fairly long running. In fact, many of them are on monthly cycles. So we need to be able to do some profiling work so that we can then take that information and set some limits on it. For example, we have an application that monitors our queues and tells us, in fact, it alerts our on-call if if one of the queues gets too deep. So if any of the queues, for example, start getting too many messages stacking up in them, it alerts our on-call so that they know that there may be a problem, and hopefully we find those problems before our customers even see them. To do that, to be able to know what threshold to set those things at, we're going to want to get a profile of the queue. We're going to want to get a graph over time that shows here's what the depth of the application is, so that we can draw a line and say here's where we want to make the limits for that queue. So we're going to build an application that does that today. We're going to build a queue profiler. And it's going to be a fairly standard multi-tier, multi-layer application. Hopefully you can all see this reasonably well. The app runner layer is at the top, and this is just a Visual Studio layer diagram, by the way. The application runner is at the top. That's responsible for configuration management in this application. So it'll be responsible for defining what are the dependencies that we're going to use. And we're not going to actually build that layer. That might be the UI layer. That might be a Windows service, or might be a console application. There's a number of ways we could do that, or maybe a Forms app. We're going to simulate that today with unit tests. So our unit tests will be playing the role of that app runner. The next layer down is the business logic layer, and its responsibility is for orchestrating the dependencies. So we're going to, the app runner is going to hand off the dependencies to the business logic, and the business logic layer applies the business rules to those dependencies appropriately. And then down below here, we've got the dependencies that are going to be involved today. And right now there's 3 of them. In fact, we may have a 4th that we'll introduce during the course of this talk. We've got a set of data services, which is primarily services that know how to read from and write to a data store, whatever that data store might be. We have a set of queue management services, which does a lot of work with queues, but the primary thing that we're going to be interested in today is the queue management services know how to query a queue to determine what its depth is. So we'll know how many messages are stacked up in the queue. Okay? And then finally, we've got a set of logging services, because this is an enterprise application. We need to do some logging. Or at least we want to be able to support our own app. Let's put it that way. Does this all make sense to everyone so far? So then we need to figure out kind of what we want to test. Now, this is not my normal process. I wouldn't normally stand up here and figure out, okay, what are all the things I want to test and what are the things I don't want to test first. I'm trying to give you some insight, though, into my thought, into the way things are, and might be done as you're going through it. But normally, when you're pair programming, you're probably going to sit down and just say, okay, what is the business rule we're going to work on, or what are the rules we're going to work on for this session. But business rules are kind of a strange thing, because they're really different for different layers. I mean, business rules, especially if you're calling them business rules when they may not be business rules. Business rules we think about as things that are important to our customers. And they are, because we wouldn't be coding them if they weren't important to our customers, right? But every layer has a different perspective on those business rules. So the UI layer is sort of, how do those rules interact? When I, as a user, do this, what do I expect the application to do? Where in the business logic layer, those rules are a little more application specific, in the sense that it's more of a when the UI layer selects, when we select to do a particular thing in the UI layer, the business logic layer, the application has to do this thing. And the data store probably makes that a little more clear. The data layer, its responsibility is to simply store and retrieve based on the needs of the business logic layer, right? So the rules themselves are not the same depending on which layer you're in. So you want to think about the rules that you're testing against as they're specific to the layer that you're working on. Now, like I said, we're going to be working primarily on the business logic layer today. So let's talk a little bit about what the rules are that we want to test here. So first off, what I've said is how many times we're going to execute. That's a business rule. All right. primarily what that means is if we say, go ahead and run 100 times, or go ahead and run for a month, the application needs to know to do that. And if it doesn't do that the correct number of times or for the correct amount of time, it's failed, right? It hasn't done what the user said to do. Same kind of thing for how often to execute. And that's probably even more important for the purposes of this application, because if it's not a consistent iteration, if it's not a consistent period between our polling of the queue, we can't really get an accurate picture of what the queue looks like. So that's going to be really important for this app. And then, of course, were the correct values output? So did we query the queue and get the result and pass that result accurately across to the data store? Those are the things I think we need to focus on here. Some things that are specifically ignored for the purposes of this discussion. Input validation is one. Now, input validation is an interesting one because it's really about failing correctly, failing well, right? If you're thinking about input validation from the perspective of the business logic layer, you're going to get your input from the UI. Now, the UI may or may not be set up to prevent users from being able to put bad data in there, and that's probably a good idea. But you can't, as the programmer of the business logic layer, assume that all the data you're going to get is accurate. But what if it isn't? Usually what ends up happening is you get an error, but you don't get necessarily a clean error. You don't get an error that easily describes what the problem is. So you may not be quite as maintainable, quite as supportable an application as it would otherwise be if it doesn't have good input validation. But this application is primarily for us, right? So if we don't set it up right, if we don't pass the right input to it, I mean, this is not an application we're delivering to the clients. And, you know, I wouldn't do this if you were delivering this application to a client. So I'm going to say we don't need to discuss input validation here. Likewise, storage requirements. You know, whether we store it in a SQL Server database or in an XML file or by calling a web service or whatever, at this point that's immaterial because we're not building the data tier. So we're not going to talk about how to store it or whether it gets accurately stored. Logging is another interesting one. Has anybody here ever tried testing logging? It's not easy to do. The reason is there's really no good business rules. There's no way to define what is testable or define a testable, a test for business for logging that is easy to determine whether it passed or not. Okay? You could write tests like the method must log something, or it must log maybe this specific thing, or it must get the value from a resource file and log that, or something along those lines. Those kind of things can be done. But they're really not descriptive, and they're certainly not business rules. Your business users do not care what you log. What they care about is the application supportable. So I don't write tests for my business rules. I actually redirect the logging into my unit tests. And so I can use it for what it is, a tool to help me develop my app and support it as we go on. And you'll see that as we get into the code. Finally, user interactions. We're not in the UI layer here, so we're not going to test user interactions at all. Everybody comfortable with this so far? So what are we going to do with it when we get started? You probably, I'm sure everyone here is familiar with unit testing in general, or the basic TDD flow, and that is red-green refactor. Primarily what that means is we will take a test, we will start with a business rule, we will build a test, and we will have that test fail. So the test runner will show it red on there. It'll show the little stop sign that says this test has failed. We'll write the simplest amount of code, the simplest thing that could possibly work to make that test pass. Okay? So now we have working code and a working test. Now we're in the catbird seat. We can refactor ruthlessly because we know that if we break anything, our unit tests will break. And now we can make our code good. And I always put the caveat on this, do the simplest thing that could possibly work, to say it isn't stupid. because I've seen so many amazing things justified with, but it's the simplest thing that could possibly work. Of course, if you're refactoring correctly afterwards, there is no such thing as anything stupid, right? Because you've gone back and refactored it anyway. So, everybody clear on this? Build a test, watch it fail, make it pass, refactor for goodness. Let's do it.
Yeah.
All right. That is the end of this thing. I think I had my resources later. So I'm going to move back to the business roles here. Let's actually start with this first business role. How many times to execute? Okay. So this is a solution I have set up. I'm going to run through very quickly, and I apologize. This is probably going to be difficult to see for those in the back. I am apparently coordinationally challenged when it comes to using things like Zoom It. So I'll try and explain what's up on the screen, and when we get into the code, I'll make sure I zoom in using the Visual Studio tools to zoom. But you'll see there's a fairly standard pattern here for dependencies. Okay, so at the very top we have the set of logging services, and there's two projects under logging services. There's the abstraction layer, and then there's the implementation layer. So you've got this logging library up at the top, and what it actually contains is simply the interface. So we have this interface. It's called iLoggingProvider, and it has some methods that we're going to use to do our logging. Very standard stuff. But that doesn't say anything about the implementation. That just says here's what we can use. I've actually got about 5 different logging providers that we could plug in here. We've got one that I like a lot that actually logs to a message queue. And then I have processes that read from that message queue and store it into a database. We've got other providers that log to disk. I've got one that logs to Twitter. It's very cool. I've got one, but I can only use it for my stuff. And we've got the one you're going to see today, which is the test context logger, which actually turns around and just writes the results of the logging into the test context. The test context is something that's actually plugged in by Microsoft into the framework as part of the test. And the results, what's written into there, actually shows up in the test results in Visual Studio, which has some real advantages. For one thing, you get to see it right away just by double-clicking on the results of the test. But also, if you're doing your testing and if you're running it, say, on a build server and you're running automated testing, the logging for the execution of those tests goes into TFS and actually gets stored there along with the results of that test. So if you need to go back later and say, hey, why did this test fail all of a sudden, you have those logs available to you. It's a nice thing to have. So again, the pattern here is abstraction layer, implementation layer. Same pattern for the other two dependencies. For data services, we've got a generic data layer that actually uses a repository pattern. And if you're not familiar with the repository pattern, there's some excellent stuff out there. Jeremy, do you do a talk on the repository pattern? Is that part of your pattern stuff?
It's part of the IEnroll.
Part of your IEnroll talk? Oh, the one I saw last week? Okay. No. So we have a repository here that's make that bigger. Right now, it only has one method. One thing it knows how to do, it knows how to save a queue depth. And it actually takes 3 parameters: the queue name, the date, date and time of the execution, and the depth itself. Did everybody see that? Okay. And then the implementation for this, I'm actually using an entity framework model. And there's the implemented repository. So again, abstraction layer, implementation layer. And then for this one, we also have some unit tests as well. And then, again, reliable messaging services, the same thing. We have a reliable messaging provider, which has a get queue depth method that returns the depth of the queue. And then our implementation here in this case, is for the MSMQ implementation. The one I use at the office actually most of the time is for IBM WebScript use. All right. I think that is all the background. Now we can actually get to coding something. So we have two projects here that are completely empty. This QMonitor project and the test project for QMonitor. Okay. So let's write some code. This is our business logic layer. Let's write something to resolve our business rule. The first business rule was how many times are we going to execute. Now we haven't defined yet what our actual front end is going to be. We said it could be a whole bunch of things. So there are a number of ways we could implement how long to run or how many times to run. Since we haven't specified yet, I'm going to say let's do the simplest thing that could possibly work, which in my mind is we pass in a number of executions and we return the result, or we start execute that many times and then exit. So we should build a test or a set of tests that verify that we execute the correct number of times when a value is passed in. Okay? Correct number of times or correct anything along a continuum, I think about testing in terms of at 0, 1, and n. That's standard mathematical stuff. So if you're verifying that anything on a continuum works correctly, if you test it at the point 0, so if I tested this at 0 executions, at 1 execution, and at some value n executions, we've probably covered the majority of conditions that are likely to fail. Doesn't mean, it's not 100%. We could actually, for example, write a loop that goes from 0 to max in, right? And check it and everything. I don't know how long that's going to take, but I don't want to have to be sitting there waiting for that code to run. So let's start off with a test that checks to make sure that we run at, when we specify 0 executions, now what should happen if we specify 0 executions?
No execution.
I'm sorry?
No execution.
Yeah, it shouldn't run. But how do we know whether it's run or not? Logger, okay, that's one way. So we could conceivably make sure that nothing has logged, but that would of course pass if we just don't put any logging in our app, right? How would we know?
Checking particular methods has been run or called.
A method call, yes, absolutely. And we can absolutely do that. And in fact, let's even take it a little more generic before we get there. If we were working with an existing version of this application, so let's say we built this application and we're done, and we run this app, and we're running it against, say, we're storing using a console application, we're storing it in a SQL database. Okay, so we run the console, we say, run it 20 times, go, and it finishes. How do we know it executed 20 times?
I'll throw a counter into it.
You throw a counter in there, or we could just look in the database and see how many rows there are.
Well, if it's one row per execution.
You're right, in theory, exactly. Yeah, if it's 1 row per execution, or however many rows there are, we could always divide too. So if it was, we end up with 3 rows per execution, we would say I expect 60 at that point. Really, what we expect is the database should have been called 20 times. If we passed in a 20, we want it to be called 20 times. And in this case, we can simulate that by checking for a method on our repository having been called. So if that save qdep method, this one right here, has been called 20 times, then we know, and it's associated requested 20 times, then it should have passed. So if we say 0 times, basically that should never be called. All right. Well, we can actually test that because we're doing what's called dependency injection. I'm hoping most of you are familiar with dependency injection at some level. Really, all it is saying that at the higher level, the dependencies are defined. What we're coding against the interface, So in this case, the repository is going to be passed into the business logic. The business logic isn't aware of what that implementation is. All it knows is it implements an IQDEF repository or whatever it is, it implements that repository interface. As long as it does that, the business logic won't care. Our layer, our code, will not care what the actual object is. So we have the ability to create fake objects and hand them in and actually use them. So we could write our own object and just count how that, that object, all it does is counts how many times it's called and returns that value. Fortunately, there are lots of frameworks out there that do that kind of work for us. The one I'm comfortable with is called Rhino Mocks. It's an excellent framework. There are a lot of other good ones out there right now. You're going to work with whatever works best for you. As far as I know, there aren't any major advantages or disadvantages to any one of them. The biggest thing when I was looking for the appropriate framework I wanted to use, this is like 4 or 5 years ago now, Rhino Mocks was the only free one that didn't call out the methods in quotes. You actually were strongly typing, basically. You were strongly coupling it to the actual code so that all the refactoring tools still worked. If I changed the name of a method, it would refactor correctly using the refactoring tools. Where many of the others at the time, you just had to quote the names of the methods, and so it wouldn't refactor those. I'd have to go back and change those later. So we're going to use Rhino Mocks, and we're going to create a mock repository, and we're going to pass that into our business logic, and then use that to see, in this case, that the code does not get called, that the repository method does not get called. Now, as we start our coding, we're going to run into the first instance where there are a lot of people who will disagree with me on whether or not it should be done this way. Again, you'll do what works best for you. I want to tell you where the conflicts exist. But there are people who say you must or you should write the failing test first, even to the point of it not even compiling. Because I'm going to write some test code, and that's going to be calling into my real code. But if my real code doesn't exist, it won't even compile. The test won't compile because I need to make that call. I like to use the tools at my disposal. So I like to actually let Visual Studio generate the test stub for me by stubbing out the framework of my object without actually writing any implementation code. I just create the interface of my object and then let Visual Studio actually build the framework of the test. Let me show you what that looks like here. I'm just going to add a class to this QMonitor library, and I'm going to call it Q, because that's actually what it's representing. Okay. Now, there are a couple of things we could have done here. I probably could have created a context object, maybe something that represents the top-level context of this application. I could have created a Q collection object so that we could handle multiple queues. But I want to do the simplest thing that could possibly work. If we need other stuff later, we can go ahead and build those other things, refactor our code so that those other objects are in there later. Simplest thing that could possibly work, in my opinion, is we simply invoke the object that we are that's representing the base set of functionality that we're going to be working with. In this case, that's a queue, a message queue. So I'm going to create a class for that, and that's going to need a method monitor. Right? And monitor is going to have to take a parameter that's number of executions. And you probably can't see this at all. Is that good? Yeah. Yes. All right. But I'm not going to write any actual implementation here, so I'm just going to throw a not implemented exception. Cool. Okay. The problem, of course, is this won't build just yet. It could if you had, if you didn't use some tools that I use. I like to use FXCop extensively. FXCop is a built-in tool for code analysis. It's in Visual Studio. I highly recommend using it, and I actually highly recommend using it at its most stringent levels. Especially if you're starting with a greenfield app, it will save you a lot of times, a lot of heartache, and will catch a lot of simple things that you didn't even realize you were doing. I learn a ton by turning these rules on. Now, if you're doing brownfield development and you've already got a big code base out there, turning these on will probably cause a lot of errors, so be warned with that. And it doesn't come with it actually comes with a little bit of a cost. So what it's doing right now, you probably can't see this. What this says is, rename type Q so that it does not end in Q. What it thinks it's doing here, it thinks I'm using some kind of, what do they call that? It was a foreign country. I'm sorry?
Hungarian.
Hungarian, thank you. That's what I was looking for. Yeah, it thinks I'm using Hungarian notation right now and ending my the name of my object with the type of data structure that it is. This isn't a Q type of data structure. It's an object modeling a Q. So in fact, it is correctly named here. So what I'm going to do is I'm going to override this error. I'm going to suppress it, and I'm going to, since it's a permanent error, it's a permanent thing, I'm going to suppress it in this project suppression file. It actually creates this global suppression.cs file over on the side here in the project. And I will not see that again. There are two other errors that are actually much more transient. It says that this parameter of the Q monitor is never used. What it's saying is this object may very well be better as a static because you're not actually using this. Well, of course, that's temporary here because I just haven't written any code yet. So that's part of the cost of adding this in here. Same thing down here. It's saying number of executions, your parameter is never used. Maybe you don't need this parameter here. These are excellent things to know, but the fact is I'm going to be using them. So what I'm going to do for right now is I'm going to suppress these in the source. And what you'll see is if we actually look at the source now, we'll see some code analysis, a suppressed message up there so that I know to go through and make sure that that is still working. And then now the compiler will ignore it, and it should compile. And part of my code review process is to make sure that all the suppressed messages are removed from code. And the ones that are in the global suppression file are valid. Okay. So now we've built, now we can have a Visual Studio generator test for us. So I'm just going to right-click in the method, say create unit tests. In this case, we've only got one thing that we're going to test. It can actually generate a whole series of tests for us. I'm going to generate the test for the monitor method, and I need to tell it the correct library to put it in. And just say go. And now it stubs out a test library for me. And my OCD requires me to actually clean this up a little bit. I apologize for that. And there we go. All right, so now we have the stub of a test. And this test would actually, there'd be a lot more to it if we had more dependencies on it, if we had more.
We lost the test method.
Did I kill it?
Yeah.
Oh, there we go. Thank you. That would have been a problem later. I would have, why isn't it running it? All right, so two more things I want to do here. I just want to talk about naming conventions a little bit, and then we'll actually move into manipulating the code. I use my own brand of naming conventions here just to make it easy, so I'm going to show it to you. I name my object, so I'm going to go ahead and change this here to the object name that's under the object under test, which is Q, the method name, which is monitor, and then a should. So the object name is Q monitor should. And we can let the refactoring tool go ahead and update that. So that's the name of this object, the test object here. And then we call the method what it should do. So you just simply by looking at the test itself, the full name of the test, class name, method name, you can actually tell what your test is trying to accomplish. In this case, QMonitor should, what? Not call the save QDepth if 0 execution is specified. Kind of long. It gets longer later. But there's no question about what that method should do. Okay? And we should be able to build again, and everything is happy. Good, so now we can actually write our test. All right. So we're going to do, you're familiar with the arrange, act, assert way of organizing unit tests? Arrange, act, assert. I'll try and organize it that way for you, just so it makes it clear what we're doing.
Thank you.
Anytime. Well, I can help. All right. So we know the number of executions should be 0. So that's good. This is the act portion right here, where we construct our Q object, and then call the monitor method with the correct number of executions. Okay. As soon as we finish this test, I guess. All right. That means I talked way too long. You guys got to tell me to shut up. All right, so we got arrange here, act, and then we're not going to use this to assert because, well, we're not going to do any, we're not actually verifying any values. What we're verifying is that we didn't call a method, right? So we're going to use Rhino Mocks to help us do that. So in our arrange portion here, I'm going to construct a mock repository. I've already referenced Rhino Mocks in the solution. And let's just do it. Our mocks. And it's going to need to be new. All right. So that's a mock repository. That's basically the context for Rhino Mocks. So it's just the top level object. And it's what will allow us to do assertions based on the mock objects that we create. And then we're going to need a mock repository object. Okay? There's 3 types of mock objects we can create. Stubs, which are basically, they don't ever fail a test. They don't ever cause a test to fail. They just give you a fake object that does the work, that goes in place, that will act in place of the object that would do the work. Dynamic mocks, which are what you typically want to use, and I'll explain why. And the other one is a strict mock. We're going to use a strict mock here because we want it to fail if anything more than 1 occurs. So if 0 occurs, or sorry, anything more than 0 occurs, right? If 1 occurs, we fail. The difference between a strict mock and a dynamic mock is dynamic mocks will allow actions that you haven't specifically told it are going to happen. So you can tell it, here's the interactions I expect with this dependency. And anything else that occurs, that's okay too, but the one that I specifically told you about has to happen the way I told it. It's better to use dynamic mocks most of the time because you're going to be building up your tests over time. So it means you're going to be building up interactions with your dependencies. If you use strict mocks, it'll work great most of the time, while you're building it, but then later on, your tests become brittle because you added interactions, and now a whole bunch of tests fail because you added a new interaction with that dependency. Happens all the time. So dynamic mocks are typically what you want to use. But in this case, we can't have any extra interactions because any interaction right now with that repository is a failure. So we're going to create a strict mock. Come on. All right. So all I did was use that mock repository that I created, construct a strict mock from the IQDef repository interface. So now we'll have a fake object in place, mock object, that implements this IQDef repository interface, and we can use it in our code in place of that dependency. All right? There's one more thing we have to do in the arrange portion of our code, and that is we have to tell it what our interactions are, what interactions we expect with this object. And in this case, what we actually want is none, but we don't want anything to call saveQdef. So what I'm doing is I'm telling it the saveQdef method, I'm giving it that, and then I'm going to say Rhino Mocks, and for some reason it's not showing compile, so I'm going to need to figure out why. All right, I have to give it parameters as well. Empty. I'm just giving it fake parameters right now because there's no reason to put in real ones, and I'm doing the simplest thing that could possibly work. 8 time min value and 0. All right. So what I told it, we're kind of in a recording phase here. It uses a record and replay metaphor in Rhino Mocks. So we're recording what we expect to happen. So we're saying this saveQdef method with these parameters, right? That was the last call. And now I'm telling Rhino Mocks, that last call, I want you to intercept that and record it, what happened. And here I'm going to tell you some expectations on it. This is going to be a little weird at the beginning, but I think you'll get it as we do two more tests here. So I'm going to say last call, ignore ignorance. Okay? Repeat. How often should it repeat? Repeat. Repeat. Never in this case. Yeah, it'll be, depending, in this case, this test is specifically for 0. But yeah, it'll repeat the same number as the number of executions. So what we're telling Rhino Mocks is that whatever that last call was here, which was a saveQdef on the repository method, should never happen. If it happens even once now, it's going to fail. Okay? Now in the assert portion, actually there is one more thing we have to do here. Very brief. We have to tell it now we're done with replay mode. Or we're done with record mode, and we're going to put it in replay mode. So I just told Rhino Mocks to go into replay mode now and expect those things that I set up. And then at the assert point here,
So record means record your expectation, and replay means watch the execution.
yes.
Redirection.
Yeah, it's a little weird.
Wrapping.
It works. And by the way, there are better syntaxes out there. There are more common syntaxes right now that actually look kind of more like a using statement, where it's in curly braces if you like that kind of thing. This is the syntax I've been using for 5 years now, so I'm comfortable with it. But you might want to look at the more modern syntax.
It just looks like the moment you create your repository until you tell it to replay all, that's continuously recording.
It's recording all the interactions that are on it, but of course the only interactions that are on it right now is this one right here. So yeah.
That's why I make sure there's no explicit call.
Right. And so now I'm going to do. Oh, sorry.
Where does the queue get the the repository?
The queue object?
Yeah.
That's an excellent question. Right now it doesn't, and we're gonna have to change that.
Okay.
Yeah, you're looking ahead of me here. Right now the test passes. Sorry, the test passes. Woo! The code compiles, but the test fails as it's supposed to. Now this is something that's really important. When we get a failed test, just to have the first time you run it, the first time you fail a test, it's not good enough to say, okay, it failed, let's go ahead and write our code. It needs to fail the way you expect it to. If it doesn't fail the way you expected it to, something is wrong. Either you're not, you didn't understand what the requirement was, or you didn't understand what the code was doing, or your test is wrong. Many, many times I write tests, I run them, I look at it, and I say, wait a second, that didn't do what I thought it was going to do. It's important to look. Now, of
It's like
course,
calling the shot. You tell where the ball's going to go.
exactly, you got to call it. In this case, I suppose I should have done that beforehand. I said, I predict it's going to fail with, make me do that next time. The method or operation is not implemented. So it threw a system not implemented exception, which makes sense, because that's what we've got in our code right now, right? All it's doing is throwing a not implemented exception. Okay, so we think we have a valid test here, or at least I think we did. What's the simplest thing we could do to this code to make it pass? Betcha. We're cranking out some code now. Actually, this is a slightly contrived example, but this is actually important. What I'm demonstrating here is I'm letting the test drive my development. I'm only doing those things that the tests tell me I need to do. Because if I haven't written a test for it, it's not important. If it's important to my customers, I'm going to write a test for it, and at that point, I'll actually write the code. That's a good teaser for all the stuff that's coming up. So why don't we take a little break, and we'll come back and we'll finish these tests, and we'll move on to a couple more. I love that.
But in fact, we're testing the monitor method. But we're testing the monitor method by seeing if
So we're basically we're using a completely fake object at the in the dependency. And we're making sure that our object here, where is it? Right there. Our code has to call that method. We know it has to call that method, right? That's part of its job, is to call that method. What happens in that method is completely outside the purview of this code. So we're not going to test that. We're going to only test that our code interacts properly with the dependency. So to some degree, it has to be aware of that outside, but the only thing it's aware of is the interface. Does that make sense? Yes. Any other questions before we get started again?
So what other mock tools do you like, or do you know that might be more modern?
This is the only one I've ever used. MOQ, they pronounce it mock. That's another good one that a lot of people like. Right, Mock?
Mock is the free one. But people only talk about free ones. I don't get that. You know, everything is free.
Yeah, but you can pick up type mock with some machines.
Yeah.
Go to the right one.
And Telerik has one as well, just mock. That's very good. So there's a lot of good frameworks out there.
Microsoft Molds.
What's that?
Microsoft Molds.
Molds? Yeah, it's a little bit different, but yeah. There was somebody else started asking questions.
The big question is, are the ones you pay for actually better than the ones that
You can do things which you cannot do in
That's
the free one.
necessary.
huh?
You can hijack methods from the real object. So that you cannot do with this free. Like let's say datetime. How you fake the actual datetime thing. There is a static method now, right? And you want to test for like in the past. Then how you do it in this thing. So type mock can do it. You hijack any
You'll
method
actually
in the
see it.
system.
I'll explain how I do that later. You won't see it, but I kind of explain how I do that kind of thing a little later.
But it's just harder, you know. Like,
It is. It's not a simple thing.
yeah.
Yeah. You have to kind of
That's what I'm saying. It's about productivity. So if people don't want to spend, like you're running the company, and you cannot spend $1,000 for these things to help you, then I don't get that. Everyone wants free. Then you want to have no one buy your software because everyone wants free.
So all you CEOs out there that are watching, make sure you buy good tools for all these people so that they...
Yeah.
But they expect you to bring them with you. from the meeting.
That seems to be, I've been reading about that lately, that people are talking about corporations demanding that you bring your development environment and your phone and all your tools along with you when you come to join a company. Huh?
It's getting crazy. They're getting so cheap.
Well, the pendulum swings, I guess, right? We'll swing back eventually. I don't know. All right. So we just finished our test where we verified that we don't call the save QDEF method if we request 0 executions. So let's move on to the next logical test in that sequence, and that's if we're at 1. So we're going to request 1 execution. And now we're going to get a little more into it here. But it also becomes a little bit easier because we have some code to copy and paste. So, and we're not using Google for it, so it's okay. Except that I did it wrong. So. Something doesn't look right there. Good. No, that's what I was hoping for. Okay, so what's our new test going to be? It should not call the save QDEF with 0 execution specified, so it should call once. Save QDEF once if 1 execution specified. All right, good. So, of course, this has to change to 1, right? Number of executions. And we have to change our repeat so that instead of repeating never, it repeats, maybe once. Is that it? All right.
What are you actually testing?
Oh, sorry?
In this test, what are you actually testing?
Oh.
Where's in the assert verify all?
Again, the verify all, what that's actually testing is
recorded.
that right there, what's recorded, right? So what it's verifying is that the last call here, which is save QDEF,
Only repeated once.
with ignore arguments, by the way. I don't think I called this out earlier. Ignore arguments means regardless of what these actually say. So save QDEF with any set of arguments gets called once, and in this case exactly once because we're still in a strict mock. Okay? So we could even say get save QDEF, we'll call save QDEF, I like this, exactly once. Okay? All right. Now I'm going to run my test, and I'm actually clicking in between the 2 tests here, so in the test class, so it should execute both tests. And as we would expect, the original one that was already passed. This one failed. Let's see if it fails the way we expect it to. And we expected, I'm sorry you can't see this. It says we have an expectation violation exception. Save QDEF with any parameters, any values, was expected 1 time and was actually executed 0 times. So it tells you exactly what you're looking for. And so that is the correct test. So now let's make it pass. Now this is not going to be quite as simple as the last one, as you already pointed out. What we want to do here is we want to make it call that save QDEF 1 time. But we don't have the dependency to call it on. We don't have a reference to it at all. So we're going to need to do that. And so what we're going to do is I'm just going to use constructor dependency injection here. Create a constructor and pass that value in. Now, in an ideal world, I don't know, there's a couple of ways you can do this here. I could just go in and create this dependency, add it in here, and then we're going to have to go back to our unit test, and everywhere where we created this object, we're going to have to update the construction of that object to add this dependency to it. And we already know that there's at least 2 more dependencies that we're going to have to add. And if we were going down the road and adding more on later and later, as we go through, we could have to go back and change many, many tests. So there's a number of ways to avoid that. Probably the most common is to just at this point pass in a container. Now, a container is really just a collection of dependencies. It's a dependency bag. So here, let's take a bag, let's put a bunch of dependencies in it, hand it off to the middle tier in this case. And then that middle tier can go reach into the bag and say, hey, I need an iRepository object. Do I have one in the bag? Here it is. And then go off and work with it. That's all we're doing. That's all that dependency containers are. So I could pass in a container here, and then I wouldn't have to worry about changing my interface anymore. But to me, that feels a little loosely coupled, loosely typed actually is what I was trying to say. Because I have no idea now what my objects actually require. I don't know that my object is going to require an iLogging provider and an iRepository. There's nothing that says that. So there's a balancing act here. I prefer to actually pass in objects, especially when it's simple. So in this case, this application is fairly simple. Now, it may grow over time, but it's a fairly simple app. So I prefer to, when in these scenarios, to actually pass in my dependencies and actually specify my dependencies here. And since I know we've already pretty much designed it, that we're going to require 3 dependencies, I'm just going to go ahead and put those dependencies in there. If I'm working on a large enterprise application, I would probably pass in a container here. For example, I tend to use Unity as my IOC container. That's Microsoft's product. There's also lots of good ones of those out there. Windsor's probably the most commonly used. If I was doing a large enterprise project, I would probably pass a reference to the container in. Okay? In this case, I'm going to go ahead and just add all 3 dependencies so we don't have to waste our time going back and refactoring and adding in dependencies every time for all our tests that we're going to build here today. So I'm going to have a dependency for a logging provider. We've got our data repository. And we have our reliable messaging provider. Okay. And then right now, the only thing we need at this point is which one? We need the repository. So that's the only one I'm going to hold a reference to at this point. Okay, now we've got a reference, and we can call some code on it. And of course, I don't have any values to pass along with it. So I'm going to use bogus values again, but I'm not going to use the same bogus values as I use in my test. That's primarily for safety. It's just so that down the road, if I ever forget to take some of my bogus values out, it doesn't accidentally pass because I used the same ones. I used 0 where in both places or something like that. So I'm going to fake up some data here. In this case, I'm just going to do, there's a random string, and I used min value, so I'll use max value here, and 100. Okay? So all we're doing in that code is calling save QDEF once with bogus data. Obviously not all that useful yet, but we'll get there. And since we're now using both number of executions and a non-static reference, we should be able to get rid of our little helpers there from FXCop. Okay, and we have our errors still from our unit test that we now have to pass in these dependencies. So we've already got, we're going to have to create the other 2 dependencies here. So quickly, let's create the logger. And this is where, when creating the logger, I told you about the test context logger. I'm constructing that here. And the messaging provider. And this is going to be a mock as well. And this one, in this case, we could make it a stub because we're not actually testing the interaction on this for at least right now. So we need. Okay. So we've got all three dependencies. We created two new dependencies, a login provider and a messaging provider. We're not going to use either of those at the moment, but we need to pass them in. Okay. And we'll need that for both of our tests. Hopefully I copied the right things. Looks like I did. All right, let's try that. Again, run both tests, and we still got some errors. Okay, so we have the same types of errors as before. We're saying the logging provider, that parameter is never used. The repository parameter is never used. Or sorry, the repository pattern is never used. And number of executions is never used. Didn't we use number of executions? No, it didn't. Okay, good. We'll get there. So let's suppress those in source and try running the test again. All right. Now, what happened here? We created a regression failure. So our new test is passing, but our original test is failing. Now, again, fairly contrived example, but there's a couple of things that we get from that. First of all, we've just done additional validation on our first test. We've made sure that it actually does fail when there is an execution, even when it shouldn't be. So we've done additional testing there, and we're letting our tests, again, drive our development. So now we can go back and repair that regression failure. And of course, what's the simplest thing that could possibly work? That work? Number of executions greater than 0? We're going to call it. Let's try running our tests again. And we're good.
You get bonus.
Sorry?
You will get bonus. From your boss.
Oh, thank you. Thank you. Much appreciated. I'm going to double my fee here. All right. So now, we're going to write the third test, which in this case is a little more fun, hopefully. Actually, it won't be really fun until we get to the next group. This one's going to be the end case. So we call save queue depth exactly once for each execution specified. Okay. And we need to come up with a number of executions. Now, I have a test library that hopefully I have referenced in here. Let's see. Okay. And this unit testing library, I only use this in my unit tests. I would never put this in production. But it's good for doing things like generating some random data and doing some helper things that unit tests tend to need. And in this case, what it does is it'll give us random data.
But then you can't repeat your test if it's failed.
Oh, don't sell me short, my friend. Yes, you'll see. It will be repeatable. But, well, actually, now I see what you're saying. If it fails, well, we'll have log. We will be logging it, so we will know how many eventually values. Because you know what we didn't do so far was in the past, after we finished our first 2 tests, we didn't refactor yet and do things like add logging and such, which we're going to do right after this test. So we could have at either point at the end of our, once we had our test passing, we could have looked for refactoring opportunities there. And of course I did that in my head, but I didn't spell it out for you, so I apologize for that. But you're right that it will be a random number, which has its benefits and has disadvantages. The disadvantage is you have to look at the log to see how many times it was executing. The advantage is sometimes it will find things for you that you didn't know. It'll find edge cases. PEX is another good tool to find those kind of corner cases, that things that you didn't even know you had dependencies on, or you didn't even know you had like a corner case where, oh, what happens when this value E is the same as this value? There's a rare condition where that occurs. PEX will find that for you, and sometimes these random tests will do that as well. So I'm just going to say I want a number of executions. I wanted a reasonable number of executions because I don't want it to, if it ends up going down the road and we end up copying and pasting this code or whatever, I don't want it to run 10,000 times here. But I want it to run at least twice because we've already tested 0 and 1. So I'm going to say, let's say 100 is a reasonable value. We get a random number between that and let's say 3. So between 3 and 100 is what that'll give me.
You extended into disability in C#.
It's that was extended. I extended in that unit testing library. Okay. And then we need to come down here and say, instead of repeat once, repeat times number of executions, which is exactly the same kind of thing we could.
Is that unit testing library? Is that something you would share with us?
It's in the code that's posted on my blog. So, do we have everything we need here? Looks like it. Let's run our tests. Okay, now the 2 tests passed, so the first 2. This one failed. The way it fails is save queue depth is called. It's expecting it 11 times. It was actually executed once. Okay, if we were to run it again, it would be some other expected number of values, but it would only be called once. So let's make it pass. And of course, what's the simplest thing that could make this pass? All right. Now, so I actually, at one of the sessions I gave this, I had a guy insist that this needed to be 1 here, and it turned out to be really kind of a good demo. So I'm gonna do that. Not a bad thing to do additional validation on your tests by putting in something you know to be bad and letting it prove it to you that it is bad. And now, of course, we failed 2 different tests, and you can actually get a profile of the failure from these 2 different tests. In the test where it's trying to call it exactly once, sorry, this is the test where it was once for each execution specified. They expected 15 and it got 14. That's a pretty good indication of what the problem is, especially when the other test, that's trying to call it exactly once, expected 1 and got 0. So it's off by 1. And so let's fix it in the simplest way that could possibly work, that is completely unexpected.
And I equals minus 1.
Equal.
Less than or equal to 1.
Less than.
All right, not completely unexpected then. And it should pass. And there we go. So now let's take an opportunity to look for refactoring. Okay? And this is where I want to show you that logging. All right? So let's do some simple logging first. Now we know we have passing tests, so if we were to do something here that would break our code, our tests will tell us. We also know that what we've done in the constructor is we've passed in a logger that is an instance of the test context providing logger, and it passes along with it a reference to the test context. Okay? So we can utilize that. And of course, we don't need to know what that implementation is, but that'll definitely help us in our tests. So we haven't stored a reference to our logger yet. We're going to need to do that. Now we can use it. Now what is this? This is the queue object. Begin monitoring, right? Actually, this is a method. Queue monitor. Begin monitoring. And of course, it's same at the end. And before we go on, let's do some more, but let's run it, make sure we didn't break anything yet. I do that a lot. I'll build a lot and run my tests a lot. And since my tests run really fast, especially in this layer, I'll probably run a little slower in the data tier, but in this layer, they're going to run really fast. I'll run my tests an awful lot. And if we actually look at the results of this now, and I don't know how well you can see it, but down in the additional information now, we actually have the information that came out of the log. So we can tell exactly what's getting logged.
What's the 5 step?
In this case, it's the level of the failure. So 5 is like informational. 0 is crash. 1 is error. That kind of thing. Those are standards from in the framework stuff. And it'll be a little more obvious what's actually happening, a little more interesting maybe, when we wrap our call to save queue depth. And of course, we don't have a value for our save queue depth, because I'm just putting in the same value that I stored. But actually, that should be refactored now. Okay. And let's end that as well. And of course, if we had any error code in here, we would be able to log errors as well, right? But why haven't I put any error code in there? Why is there no error handling in here?
Because it wasn't in the business requirements.
Because I haven't written any test for it yet. Exactly. Done saving queue depth. Let's take a look. And they all pass. And let's see if we look at the once for each. And you can see that we actually have a bunch of logging information. You can also see that it makes it obvious that we're saving the same value every time, so we're actually still using fake values. So if you had run this in an automated way, you look back at it and I can see what happened here. We're storing the same value every time. Yeah, it'll contrive. Does this all make sense so far? The running our tests at 0, 1, and n, and interacting with the repository here. All right, let's move on. Then. So we've talked about how many times to execute. Let's talk very briefly about how often to execute. So you see we can test interactions. It's a lot harder to test things that are in the framework. For example, as you mentioned earlier, testing datetime or testing thread sleep, right? This would probably, I would normally, if I was just writing, oh, I've got to put a delay in there, what I'd probably just do is pass in some value for how long, maybe in milliseconds or maybe in a time span object, and say just go to sleep for this long. But think about how we would test that. That's a tough thing to test because we're testing between, it's delay between executions. And we don't have access to that time between the executions. What we have access to is the entire method. We can call it, we can call the method and we can see what it returns. So we could test it by saying maybe, well, let's execute twice and check to make sure that the minimum time span is included in that. So we could test the minimum value. But we've got all this other business logic in there that we're doing, so all these other things that we're doing in that method that make it really hard to check exactly with any precision how long our delay is. That's if we just call it directly. But what if we made delay a provider as well? What if we created an iDelay provider? Wrap thread sleep in this delay provider, give it an interface, and then call that. And then the best part about all that is we could take all the junior developers and send them off and say, you go build this iDelay provider. We don't have to deal with it here. And they can test that. They can write the unit test for it, but they're writing the unit test right against the metal of that provider. So there's nothing else involved except the delay. So you can get very tight tolerances on that. You can start a stopwatch object in system diagnostics, right? Run the delay, stop it, and check to make sure that with very tight tolerances that your delay worked correctly. And then we don't have to worry about it here in our business logic. We're not worrying about testing something that's in the framework. We don't have to. All we have to do is call and make sure our code interacts with that provider correctly by passing it the right values and calling it at the right time. The same things we're doing with the data provider. That make sense? Okay. So let's not do that. Let's move on to the next one, because we've already seen how to do that. So let's move on to the next one, which is to test that we've got the correct values. Now, the correct values here is interesting, because we don't supply the correct values from outside. You think about what our code is doing. Going, each time it executes, it's going to the reliable messaging provider, getting a value, taking that value and passing it along with some other values to the data provider, right? So our unit tests never see that value. They don't know what that value should be. So how are we going to know what it should be when it gets passed along? And how are we going to test it? Well, and the nice thing about Rhino Mocks, or one of the many nice things about mocking frameworks, is that they allow you to specify the results of interactions. So before we just checked for interactions themselves, we said, did this interaction occur? Did we call save QDEP? We can check to make sure save QDEP gets called with the right parameters. But we can also say we have this other provider here called the reliable messaging provider that's going to get called, and its get QDEP method is going to be called. We can, in our tests, say, when this gets called, pass this value, return this value from it. So act as if you got this value. And we set that up in our test. And you'll see that happen here in a moment. So we can tell it, here's how you should interact. Here's the data you're going to provide. So now we know from the unit test, we tell it, we want you to return 5. Okay? So we know the Q provider is going to return 5. We can check for that 5 on the data provider and know that we're passing the data along correctly. Let's do that. All right. So in this case, I'm going to copy the test that actually calls it exactly once, because we don't need to test it multiple times here. We're just checking the data value to make sure that data value is correct. And there are actually 3 data values on the data provider, right? I write a separate test for each one. You're going to do what makes most sense for you. Some people prefer to write one test that checks all 3. There's nothing wrong with that. I find that I get better data, more information when I have a problem by having a separate test for each one, because it tells me something if all 3 of those tests fail. It tells me something different if only one of those tests fail. Gives me more information when I'm trying to troubleshoot. So in this case, this test is only going to be for the Q depth. So what should the Q monitor do? Q monitor should pass the value from the messaging provider, or sorry, pass the what value? The Q depth value from the messaging provider to the data provider. That's the repository. Trying to be consistent with my naming. Why doesn't it like that?
You have a curly brace there before your method.
Really?
Yeah, scroll up.
Right there?
Yeah. You also need one down the bottom.
Thank you. Make sure this compiles. Good. All right. Pass the QDEP value from the messaging provider to the repository. All right. So let's set this test up. We're going to execute it once still. The difference being we're going to pass in a value, or we're going to get a value for the depth. So let's set a value. Let's pick one. And of course, we want to use a random value. So let's do, I don't know, int 32 max value. So that's a value between 0 and max int 32. So it's going to pick a random depth value there. Okay. Same caveats as before about repeatability versus better tests. And then we're going to expect that call to say, oh, first we have to tell it, the messaging provider has to know to return that, okay? So messaging provider get QDEP with the Q name, which we don't have. And what we're going to tell it, and I have to store the value. Come on. All right. Rhino Mocks. Last call. And again, there are other syntaxes for this. This is the one I'm most comfortable with. So now, when getQdef gets called, ignoring the argument, so with whatever argument it is, we're going to tell it to return, and the object we're going to return is depth. Okay? When it gets called, return that depth value. Okay? And then save QDepth needs to be called with that depth value as that parameter. And we run into a problem here. We're telling it to ignore arguments right now, right? Which means it can be called with any arguments, and we're not going to validate that. Which is great, except that ignore arguments is an all or nothing thing. It either has to ignore all the arguments or ignore none of them. We can't tell it to ignore only one. However, we can, there is a separate syntax that can place constraints on those parameters. And with the constraints, we can set it to only, what did I do? Repeat once, return What return there? Shouldn't return anything. We're saved QDEP, it's a void, so it shouldn't return. We have constraints. Okay, there we go. And you have to have one constraint for every parameter. It must always match exactly the number of parameters in the method. So we've got 3 parameters in this method. The first 2 I don't care about in this test. So they can be anything. So I'm going to constrain them to anything. So if you can't read that, it's specifying a Rhino Mocks constraint, and the constraint is anything. Okay? So it won't fail. It'll work no matter what. Same thing for the next one. Now the third one is the one we're interested in, and they are in order. They have to be specified in the order that the parameters are specified. And in this case, we want the constraint, we want it to be equal to depth.
Right. Doesn't this completely ignore arguments?
Yeah, so can you remove the ignore argument?
It will ignore arguments, but then it will constrain those arguments. So it's going to ignore them first, but then later it's going to constrain them.
But if we are constraining, why we don't have to ignore?
Well, if we have to remove if we were to remove the ignore, I'll tell you what would happen, and that might explain. If we were to remove ignore arguments here, what it's going to do is it's going to expect these 3 arguments, and then it's going. If it doesn't get those 3 arguments, it's going to think this isn't the one I'm interested in here. Yeah.
Okay, and then if you check the method signature, that test has no other static compiler checking that you change the order here, right? Unless you use
You know what? I never tried the refactoring tools to see if I reorder the parameters, will it reorder the parameters here? I doubt it.
I don't think it would, but the test you will not know where it failed, and it's hard to find it, right? Unless you use that link use syntax more. I think that when a lambda expression is more able to validate than this thing.
Think about that one for. I don't know. You know what? Afterwards, let's try it. Let's see what happens. All right. We have everything we need. We set the number of executions.
What's going to happen with your messaging provider being a stub and not a
Good question. So the fact that it's a stub just means I'm not testing the interaction with it. So it's not going to fail if something on it gets called that it shouldn't be, for example. So the only thing I'm doing with that stub right now is I'm telling it to return a value.
Right.
I'm not checking does that actually get called. So if this method, the get QDEP, doesn't get called, it's not going to fail.
Okay.
And that's what the stub does. Now, if I made that like a strip mock,
Right.
then it would expect that to get called, and if it doesn't, then it might throw an error.
Okay.
All right, let's give this a shot. No need, because it's ignoring these arguments. Is that the one you were talking about? Yeah. Yeah, those are being ignored completely, so it doesn't matter. Right here is where it matters.
So the test should say.
The test should fail because we haven't ever passed, nowhere in it, in our code have we passed that value on. So what do you expect the failure to be?
That it's incorrect value being passed.
Yeah, it should say what? I'm passing it 100 when I expected some weird number. Okay, and we got a slightly different error. Now this was a much better demo before I installed Visual Studio 2012 on this machine. Apparently there was some kind of update to the framework done, maybe with the 4.5 stuff, or who knows. This used to actually say here, and it wouldn't do it at this point, it would do it when we were running the test. It would say, for example, expected 1, 2, 3, 4, got 1, 2, 3, 4. Yeah, very annoying. And it takes a while to figure it out the first couple of times. And what it's really saying there is it's an int64 versus an int32. And Rhino Mocks, or in the framework, the way it compares them, it would compare them differently. But now it captures that in my code beforehand and totally ruins my demo. So, but we can go in and actually, the depth value is actually an int32, or sorry, an int64. I think that's all we need to do to make that happen. Okay, now did it fail the way we expected it to? All right. So, this is going to be hard to hear, hard to see, but save queue depth where anything, and 65217635. It was expected that to be called once, and it was actually called 0 times. And the save queue depth up here with these values, including 100 at the end, was expected 0 times and was actually called once. So it's telling us exactly what we expected. So let's go update our code, make it work. Now what do we have to do here? Well, now we need a reference to our messaging provider. Oh. All right, hold a reference to it. And now we can get our depth here from the messaging provider. Get queue depth. And we still don't have a queue name to work with. So you can see there's still plenty of stuff we're going to have to do here. We're not passing in an actual real queue name yet. Okay, I probably need to have this in 64. I should have just used a var there. Come on. Bam! All right. We get depth from the messaging provider, and then we pass it in right here, and of course we also log it there. Is that all we need to do? Come on, guys, help me out here. I don't know what I'm doing.
It needs to pass next to null refactor.
I'm sorry?
It needs to pass next to null refactor.
Oh, okay. And it did.
Okay.
Cool. What should we refactor to?
We could at least get rid of the code warning suppression.
Good call. I like you. In our logging, now we can see saving queue depth, and it tells us what our value is for the queue depth that we're saving. Cool. And yes, we can go back in and make sure that our suppressed messages are good. Anything else we should be doing here, refactoring wise? And that code's not terrible. It's not great. We still don't have, as we mentioned earlier, we don't have a queue name, so we probably want to make that a property of our object. I'm not a huge guy, where we have to tag, especially if it's a automatically implemented property. If we just tell, Visual Studio or tell C# just implement this, I'm not huge on having to go through and test our properties specifically. They should be tested as part of our other tests. If that code doesn't get exercised in our other tests, we might want to question why do we even have it there? Is it really necessary? For example, if we never do the store of a property value, but we do gets, maybe we don't need, maybe it doesn't have to be a read-write property. Maybe it only needs to be a read-only. Because our tests should be testing every interaction that's going to happen from outside, or at least that we anticipate happening from the outside. If none of our tests are exercising that bit of functionality, we may not need that bit of functionality. Okay? Does this all make sense? How we can use Rhino Mocks to basically get in between, get inside code that we wouldn't otherwise have access to by being able to provide the results of interactions that we wouldn't even be able to see if we weren't, if we couldn't use Rhino Mocks or we couldn't use a mocking framework to do that. The other thing it's really good at, it's really useful for, and I don't have a demo of it, is you can tell Rhino Mocks when you make a call, a specific call, you can tell it, throw an exception, throw a particular exception. So there's really no excuse to have any code that's not covered, because if you're expecting, for example, you expect that a call to the data provider could result in any of 3 exceptions, or 2 exceptions, and you catch the generic, system.exception just in case. You can now test every one of those paths by simply setting up a test for it and telling the repository, throw that particular exception, and you can make sure that your code handles it correctly, including doing all the appropriate logging, and you'll see that logging in your tests. That make sense? Any questions about any of this? Oh. How are we doing on time? About done. Cool. All right. We could talk a little bit about I don't have any demos for that. I do have code in the sample that actually shows the database interaction. I'm a firm believer that if you are, you're building a data repository, you need to test the fact that if its job is to store data and retrieve data, you have to test that it successfully stores and retrieves data, which means you actually have to write stuff into the database and read it back out and see if it actually did it. There are a lot of people that will disagree with me on that. In fact, some very big names in the testing world, in the unit test world, will tell you that they consider anything that touches the database to be an integration test, not a unit test. I can't accept that. For me, if my customers need it, I need to test it. And I look at the data layer as one logical layer. My .NET code, my repository code, and my database code, whatever that database is, whether it's SQL or Oracle or XML or whatever, all of that is one layer to me, one logical layer. And I test it all as one logical layer.
So if you're persisting stuff to the database, how do you reset it like between tests?
I actually, most of my tests will either write stuff out there that's random data that I know to look for, check it, and delete it at the end, or specifically go out if I know the database is generally populated. I'll go out and actually query the database using code that is not part of the code that I'm testing. So actually, if we look at the database stuff that I have here, I have an enterprise ND framework library that's here for the for this model. Ooh, one table, bitch. I've got ND framework code to do that. In my unit tests, it actually uses a ADO.NET and goes out to that database. Now, again, that's very specific logic. It's a test for that specific implementation. So to do that, you can't write generic tests that'll work for any repository at that point. If you're trying to do that, then all your testing is your .NET, it's the top level stuff. You can also do it, another good way of doing it, in fact, is to simply create and destroy the database every time you do it. In fact, when I'm testing things like my reliable messaging library, especially MSMQ, where it's very easy to create queues. So I'll actually, the first thing I'll do in a test where it's actually interacting with that with the message queue is I'll create a queue with a random name, interact with it, check it, make sure it's working right, and then destroy it. And that has the other advantage of being a resource that nobody else knows about, so nobody can actually, nobody who's on a shared database, for example, is actually going to put more data into it because it's something I just created. So if you can create a random database like that, that's a good way to do it.
Is there a difference between regression testing and integration testing?
Regression testing?
Yeah.
Yeah, regression and integration. I'm sorry, what was that last
And
thing?
this is really, really related to the.
You know, it is what it is. I let my QA people deal with that as much as I can. I tend to focus as much as I can on developer testing and just making sure that my code is covered and I've got all my business rules covered. And then if they do find a bug, so if they find something, say in a regression test or in an integration test, I make sure that the first thing I do is write a test that exposes that, so that if it is recreated in the future, I'll know about it. But I don't spend too much time worrying about whether those guys are doing integration tests or regression tests or what have you. But I also depend on them to cover my butt. So if they need any help, they can call me. That makes sense? All right. Did I answer the question at all? All right. Anybody else? Yes. What did I do with it? I think it cut off at 140. And the real nice thing about that actually was Twitter has this feature where if you repost the exact same thing over and over again, if you repeat it, it only sends it once. So I was able to use that to actually, I could just go ahead and keep sending the same thing, even if it was just the same thing over and over again. I would only receive it one time at Twitter. And that was a very useful feature. Of course, it can get in your way too, but it's easy to get around because if you want to get around it, you could just pretend with a GUID or something like that, and you're guaranteeing you're changing it. Of course, you're using up space in your 140 characters too. Primarily, I used that for alerting. So if I was sending only high priority messages to it, and it was an account that only I had access to, it was a locked account, and I did that so that because Twitter also has a feature where you can send it to SMS, but only during certain hours. So I had that account set to send to me via SMS, but only during, between 10 a.m. and 6 p.m. or something like that, which was the only time that I cared about it. So I was using the features of Twitter to help me. There's probably more than you really wanted to know about it, huh? It's a good tool for a lot of things. I'm at BSStall on Twitter. Please feel free to interact, ask questions. If you have any questions that come up, send them to me. Try and get them up on my FAQ on my blog. Thank you guys for inviting me here. It's been fun.
Didn't you have a resources slide?
Yeah, I did. I had a good call. Here's the slide deck. So if you need it, you want to download that slide deck.